bases and salts. Now we will learn preparation of insoluble salts. Salts which are insoluble in water. Okay. And the method to prepare these insoluble salt is, the first one is by double decomposition precipitation reaction. As a result of this double decomposition precipitation reaction, the precipitate that comes out is the desirable salt. Okay. So that in that way you can prepare carbonate, sulfides, chlorides and sulfates which are insoluble. But one thing you all have to remember, that whichever sulfate, chloride, carbonate or anything you want to prepare insoluble salt, you have to start with a soluble salt. Soluble salt solutions. You cannot prepare insoluble salt starting with an insoluble salt. This is the condition. So let us see preparation of carbonates. Let us suppose we have to prepare calcium carbonate, and we know that calcium carbonate is insoluble. So we have to prepare calcium carbonate. So choosing the reactant, this calcium carbonate will help you to choose the reactants. Okay. So we will take any soluble calcium salt. So now calcium has two soluble salt, calcium chloride, calcium nitrate. Any one you can take. I have written here calcium chloride. Plus this has to react with a soluble carbonate which will furnish that carbonate anion. So sodium, potassium, ammonium carbonates are soluble. So we can take sodium carbonate here. So soluble salt of calcium plus soluble carbonate undergo double decomposition, and this calcium will combine with this carbonate and calcium carbonate will precipitate. This downward arrow shows that this is a precipitate, and this Na and Cl will come out in the form of NaCl which is soluble. So the precipitate is the desirable salt. Second, you can prepare any insoluble carbonate starting with its soluble salt. Second, sulfides. Sulfides SO3. For that also, let us suppose you have to prepare copper sulfite. So take a soluble copper salt. Now copper chloride is soluble, sulfate is soluble, nitrate is also soluble, any one of your choice, plus soluble sulfide, sodium sulfide is taken over here. Again this will undergo double decomposition. Copper will combine with sulfite ion and copper sulfite will form, and sodium chloride is a soluble byproduct over here. So the desirable salt is copper sulfite. Third, we can prepare insoluble sulfides even. Sulfide S2 minus anion. Let us suppose we have to prepare zinc sulfide. So what we will do, we'll start with a soluble zinc salt. Again, you can take zinc sulfate, chloride or nitrate. Now here nitrate I have taken. So ZnNO3 whole twice plus Na2S will give you ZnS which is an insoluble salt and NaNO3 which is a soluble part. So starting with soluble salt of zinc, you could prepare insoluble zinc sulfide. Then comes chlorides. In this way you can prepare any insoluble sulfide. Then comes insoluble chlorides. Which chlorides are insoluble? You know, mercury, silver and lead chloride. When it is room temperature water it is insoluble, but hot water it is soluble. So let us suppose we want to prepare silver chloride which is a curdy white precipitate. So take silver nitrate plus NaCl soluble chloride and desirable salt. You have to prepare silver chloride, so we have taken silver nitrate plus NaCl, so AgCl plus NaNO3. So this AgCl is a precipitate which is the desirable insoluble salt. Then if you want to prepare sulfate, let us suppose we have to prepare lead sulfate. I am giving one example over here. Now, whenever an insoluble salt of lead is the desirable salt, you have to start with lead nitrate because lead has only one soluble salt. So there is no other choice instead of taking lead nitrate. So lead nitrate is taken, treated with soluble sulfate, sodium sulfate. It will give lead sulfate which is insoluble and NaNO3 soluble part. So in this way we can prepare insoluble carbonate, sulfides, chlorides and sulfate. In this way you can try with other substances and practice the equations. So this is one method of preparation of insoluble salt. The second method of preparation of insoluble salt is by direct combination. Direct combination or synthesis. You know, two elements combine and form only one product, that is direct combination. Now here you can prepare zinc sulfide, copper 2 sulfide or iron 2 sulfide. Even lead 2 sulfide can also be prepared by this method. Here metal is taken, sulfur mixed with sulfur and heated it. After heating, these two elements combine, zinc and sulfur, copper and sulfur, iron and sulfur combine and form their insoluble sulfide. So this is Zn plus S is equal to ZnS, zinc sulfide, Cu plus S, CuS, Fe plus S, FeS, which is iron 2 sulfide. So this is the second method of preparation of insoluble salt. As I told you, to prepare an insoluble salt, we have to start with a soluble salt. Okay. So if soluble salt is not available or you are asked to prepare insoluble salt to insoluble salt, then what to do? Then there is a different way. There are two steps. So to prepare insoluble salt from another insoluble salt, let us suppose we have to prepare PbCO3, lead carbonate, which is insoluble, starting with PbO, lead oxide, which is also insoluble. Okay. So in the first step, we will convert the given insoluble salt or substance into a soluble salt, and then that soluble salt, treating with a suitable substance, we will convert into desirable salt. Okay. So let us start. So this is equation 1 and this is equation 2. So in the first step, PbO, and we know that lead has only soluble salt, which is lead nitrate. So PbO can be converted into PbNO3 whole twice by treating it with dilute HNO3. So PbO plus HNO3 will give you PbNO3 whole twice plus H2O. Now this PbNO3 whole twice is a soluble salt. So we have converted this insoluble into soluble. Now this lead nitrate, now it can be filtered, and this lead nitrate is treated with sodium carbonate to convert it into lead carbonate. If we have to prepare lead sulfate, then we will treat it with sodium sulfate. Lead chloride, then sodium chloride. So depending upon the desirable salt, we can choose this substance. So this is how we can convert insoluble to insoluble in two-step procedure. Next term is hydrolysis. Hydrolysis is a process of a salt of strong acid and weak alkali, or weak acid and strong alkali. When dissolved in water, it reacts with water and forms its parent acid and alkali. That is called hydrolysis. In simple words, if you dissolve a salt in water, it will combine with water and form an acid and an alkali as a result, which are called their parent acid and parent alkali. Okay. For example, so in this way, if you dissolve a salt in water, we can find out what will be nature of the solution, whether the solution will be acidic, alkaline or neutral. For example, hydrolysis of a salt of strong acid and weak alkali. As a result of neutralization of acid and alkali, we get salt. So strong acid and weak alkali, if undergo neutralization, a salt form. Let us suppose the salt is ammonium sulfate. Now this ammonium sulfate is formed from ammonium hydroxide and sulfuric acid. Okay. So when it is dissolved in water, it will combine with water and give its parent alkali and acid. What are parent alkali and acid? From which this salt was made by the process of neutralization, by the reaction of neutralization. So they are called as parent alkali and acid. Now see, out of this, ammonium hydroxide is a weak alkali and sulfuric acid is strong acid. So the resulting solution will be acidic in nature because strong acid will dominate. So the resulting solution will be acidic in nature. Second one, hydrolysis of a salt of a strong alkali and weak acid. If a strong alkali reacts with weak acid and forms a salt by neutralization. We can take example of potassium carbonate. What can be the neutralization reaction for formation of K2CO3? Strong alkali KOH and weak acid H2CO3. Okay, so if it is dissolved in water, it will combine with water and give back that alkali and acid. So parent alkali and parent acid. So this is KOH, which is strong alkali. H2CO3, we all know this is a weak acid. Okay, so the strong alkali will dominate and the resulting solution will be alkaline in nature. So solution of potassium carbonate, sodium carbonate will be alkaline in nature. The third one is hydrolysis of a salt of strong acid and strong alkali. If acid and alkali both are strong, undergo neutralization and salt form. Let us suppose K2SO4, KOH and H2SO4. Okay. When it dissolved in water, it gives back KOH and H2SO4. Both are strong, so they will neutralize their power, each other's power. So the resulting solution will be neutral in nature. Similarly, we can think about a salt of weak acid and weak alkali also, like sodium acetate, CS3COONA. Now we will see some important terms related to salts. This was already done in 9th standard, so it's just a revision. First, anhydrous salt. A salt that does not contain any water of crystallization is called anhydrous salt, like NaCl, PbNO3 whole twice lead nitrate, NaNO3 sodium nitrate. Okay. Second is hydrated salt. A salt which contains water molecules loosely attached to its one molecule. So here water molecules, 5 water molecules loosely attached. This dot shows loosely attached to one molecule of copper sulfate. So this is hydrated salt. This is Na2CO3.10H2O, sodium carbonate decahydrate. Third type is water of crystallization. The water molecules loosely attached to one molecule of a salt are called water of crystallization. So the salt is hydrated salt and the water molecule are water of crystallization. So these are some other examples: FeSO4.7H2O, green vitriol, ZnSO4.7H2O. Next term is deliquescent substances. What are deliquescent substances? Some substances can absorb moisture. They are water soluble substances. They absorb moisture from air and dissolve in the absorbed moisture and convert into liquid state. These are called deliquescent substances and this phenomena is called as deliquescence. These salts are anhydrous calcium chloride, anhydrous magnesium chloride, anhydrous ferric chloride, potassium hydroxide, sodium hydroxide. Now table salt, sodium chloride gets wet during monsoon or if it absorbs moisture, but it is not deliquescent. It is anhydrous salt, but it will have a small quantity of magnesium chloride or ferric chloride which are deliquescent and make it damp or moist. Okay. Then hygroscopic substances. These are just little bit similar to deliquescent substances. They also absorb moisture from air but does not change their state. Okay. These are hygroscopic substances like calcium oxide, concentrated sulfuric acid. These are used to remove water from some compounds. Efflorescent salts. Crystalline salts, when they are exposed to air, they lose their water of crystallization and form a powdery substance or mass. These are called efflorescent salts and that phenomena is called as efflorescence. These are washing soda, sodium carbonate decahydrate, global salt, sodium sulfate decahydrate. So some salts like FeSO4.7H2O, that green vitriol also, blue vitriol also, if you leave them open to the atmosphere, then they will lose their water of crystallization and change into powdery mass. So these are the terms. Now the topic is related to your practical chemistry part which you are already writing in the journal, salt analysis. Okay. So this is related to cations. The cations can be identified by treating their soluble salt solution with sodium hydroxide solution and ammonium hydroxide solution. So the cation, the soluble salt of the particular cation is dissolved in water and that aqueous solution is, if it is soluble in water, is treated with sodium hydroxide, First we will add a little drop by drop and see the changes. Once the observations are done, then we add excess of sodium hydroxide and see what happens. The precipitate and color of the precipitate will be different with different cations. Okay. Similar thing we will perform with ammonium hydroxide also. First little and then in excess. So whether the precipitate will dissolve or not. Okay. So the first we are starting with copper 2 plus ion. Now copper 2 plus ion salt solution is first treated with sodium hydroxide. Little sodium hydroxide, it will give pale blue PPT. And then if you add excess, this PPT will be of copper hydroxide, which is insoluble. Add excess of NaOH, it will remain insoluble, the precipitate. So no reaction is taking place. So pale blue PPT, which is insoluble in excess. Same solution you take in separate test tube, copper 2 plus ion solution, treat it with ammonium hydroxide. With little ammonium hydroxide, it will give pale blue precipitate, because here also copper hydroxide will be formed. Both the cases, little solution copper hydroxide will be formed, which is pale blue. If you add excess of ammonium hydroxide, this precipitate will dissolve. That means it is reacting with more of ammonium hydroxide and forming a complex. Okay. And that will turn a soluble deep blue coloration will come. So the entire content will turn into deep blue color and the precipitate will dissolve because reaction is taking place. So this is about copper 2 plus ion. Then comes zinc 2 plus ion. Any soluble zinc salt if you take, treat a little, two different solutions you have to take. First part you treat with sodium hydroxide. Little, it will give gelatinous white precipitate of zinc hydroxide. Add excess of sodium hydroxide, the precipitate will dissolve. That means reaction is taking place, a complex is formed, that is sodium zincate will form. So little gelatinous white precipitate, excess precipitate soluble. Then if we treat zinc salt solution with ammonium hydroxide, little, similar manner gelatinous white precipitate of zinc hydroxide will come, and if you add excess, it will dissolve and form a clear solution of a complex. Now the name of the complex here with copper and zinc, excess ammonium hydroxide, copper will be tetraamine copper hydroxide. Again you will learn this in practical chemistry, and here tetraamine zinc hydroxide. So next ion is lead 2 plus ion, third. Now lead salt solution, if you treat with sodium hydroxide, little chalky white precipitate of lead hydroxide. In excess, it will dissolve, forming lead complex with sodium hydroxide. Sodium plumbate will be formed and it will be soluble. So with sodium hydroxide, little chalky white, excess soluble. With ammonium hydroxide, if you add to this lead salt solution, little chalky white precipitate of lead hydroxide. Excess if you add, it will not dissolve. That means it is not reacting. The precipitate will remain insoluble. So this is difference how you can differentiate Zn2 plus ion and lead 2 plus ion. You can use ammonium hydroxide. Little, both will give white precipitate, but excess zinc precipitate will dissolve and lead will not dissolve. Then comes Fe2 plus ferrous ion, NaOH, little dirty green precipitate, excess insoluble. NH4OH, dirty green precipitate with little, insoluble in excess. Both the cases same manner, it will give precipitate which will be insoluble. Fe3 plus ion, ferric ion with NaOH, little reddish brown precipitate which will be insoluble in excess. With ammonium hydroxide also it will give reddish brown precipitate. With both the cases hydroxide FeOH3 will be formed and which will be insoluble in excess. Then comes ion, calcium 2 plus ion. This calcium 2 plus ion will react with sodium hydroxide if you add little and gives a milky white precipitate. All are white precipitate, different names are given, which is insoluble in excess. With ammonium hydroxide, no reaction will take place. So this will not give any precipitate with ammonium hydroxide because it will feebly ionize, give very less OH ion and which will not be able to precipitate calcium hydroxide. So calcium will give precipitate only with NaOH. Cation is non-metallic cation, ammonium ion. Now this ammonium ion can be identified by treating with concentrated sodium hydroxide. This is concentrated sodium hydroxide, and it will give ammonia gas and other byproducts. Now this ammonia gas is identified by its smell. If you bring a glass rod dipped in HCl, it will give dense white fumes of ammonium chloride. This is how you can identify ammonium ion. So these are all cations. Amphoteric nature of zinc, aluminium and lead. Metal, their oxides and hydroxide. Now what is amphoteric nature? Amphoteric nature of a substance is when the substance react with both acid and alkali and make salt. So now we will first take zinc, aluminum and lead metal. When these metals react with acid, they make their salt and displace hydrogen. With alkali also they form salt and displace hydrogen. For example, zinc reacts with dilute sulfuric acid will form ZnSO4 and hydrogen gas. So ZnSO4 salt is formed, hydrogen is displaced. Same zinc when reacts with alkali, sodium hydroxide, but here the alkali should be concentrated. The acid was dilute here. Concentrated alkali and we have to heat, then it will form sodium zincate Na2ZnO2 and hydrogen gas is displaced. Now aluminium metal reacts with sulfuric acid, dilute acid, then it will form aluminium sulfate in Al2SO4 and hydrogen gas is displaced. So metal reacts with dilute acid, forms salt and hydrogen is displaced. With alkali also, aluminium reacts with sodium hydroxide, concentrated one, in presence of water, form sodium aluminate, salt and hydrogen gas is given out. So salt and hydrogen there. Lead will react with concentrated HCl and from lead chloride and displace hydrogen. Same way lead will react with concentrated NaOH, on heating will give sodium plumbate, a salt and hydrogen gas. So salt and hydrogen. Similarly their oxides. So the next set is their oxides. This is A and this is B. Zinc oxide, aluminium oxide and lead oxide. Now zinc oxide, ZnO, will react with sulfuric acid which is dilute. These all acids are dilute acids here. Dilute sulfuric acid and form zinc sulfate and water, salt and water. With sodium hydroxide concentrated, on heating, sodium zincate and water. So zinc oxide with alkali, salt and water. Acid also salt and water. So this is amphoteric nature. Aluminium oxide with acid, salt and water. Aluminium oxide plus sulfuric acid, aluminium sulfate and water. Aluminium oxide, sodium hydroxide concentrated, heated, sodium aluminate and water. So salt and water. Lastly, lead oxide, PbO2 with dilute hydrochloric acid on heating at 273 Kelvin. It is 273 Kelvin. It will give lead chloride, PbCl4 and water. So salt and water, PbO2, alkali, salt and water, NaOH, concentrated one, on heating, sodium plumbate and water. So it is giving salt and water with acid as well as alkali. So amphoteric nature of these oxides. Okay, the last is their hydroxide, zinc hydroxide, aluminium hydroxide and lead hydroxide. Reaction with acid, reaction with alkali. ZnOH2 plus H2SO4 dilute will give zinc sulfate and water, salt and water. Zinc hydroxide, ZnOH2 and alkali concentrated again and on heating, sodium zincate and water, so salt and water. Aluminium hydroxide, AlOH3, dilute H2SO4, aluminium sulfate and water, salt and water. Aluminium hydroxide, NaOH, concentrated on heating, NaAlO2, sodium aluminate and water, so salt and water. Lead hydroxide reacts with nitric acid. Now why are we not writing HCl or H2SO4? Because here we are writing H2SO4 but lead sulfate is insoluble, so reaction will stop. Lead nitrate is soluble, you all know that. Okay, so PbOH2 plus HNO3 dilute, lead nitrate and water. PbOH2, NaOH concentrated one, heated, sodium plumbate and water. So salt and water, salt and water. Same reactions can be written with KOH also. So this is end of your chapter acid, bases and salt. Thank you.